Okay, we've done a lab on constant velocity and gotten some definitions. Now we're going to talk about ways to represent constant motion. And the first thing is with motion maps. What we're going to do is we're going to place a dot showing the position of the object at each second. All right, so it might look something like this. I'll put a dot here. Here's where the object starts out. That's t equals 0. Then it moves to here. That's time equals 1. Another dot for 2. And then another dot for 3. Well, let's say it does that. Then it sits still. Well, it's not going to move for the next couple seconds. It's 4 and 5. And then go back this way. And maybe it does something like this. Okay. Now we can describe the motion. Okay, from t equals 0 to t equals 3. How was it moving? It was moving in the plus x direction at a constant speed. Okay? Then after 3, it stopped for 1-2 seconds. From t equals 3 right here, there's 4, there's 5. T equals 5. So from t equals 3 to t equals 5, we're going to say it is at rest. Then lastly, from 5, 6, and 7, so from 5 to 7, it moved in the negative x direction at a constant speed. And one thing I can tell, how did the motion differ besides the direction? Well, it went a much farther distance each second, from 5 to 7, than it did from 0 to 3. So we can say that it was faster than from 0 to 3. We can tell it's faster because the line is longer. So if it's constant speed, the dots are equal distances apart. Now, there's other ways we can represent it. We can represent them in a position versus graph that can be qualitative without numbers, or it can be quantitative with numbers. So if we don't have numbers, we learn some things from our lab. We learned that the slope equals the velocity. Okay, if it's steep, it's going fast. Now, if it's constant velocity, it's going to have a constant slope. So it's going to give you a straight line. So section A is a straight line, section B is a straight line, section C is a straight line. So for each of those intervals, the velocity was constant. Later, when we start doing changing velocities, the lines can be curved. So now let's describe the motion for each one. A is a constant velocity in the plus x direction. All right. Then B, okay, its position is staying the same. The slope is 0, so we can say that it is at rest for that part. And then for section C, we can say that it is a constant velocity Okay, so it's a straight line in the minus x direction. Okay, it has a negative slope, so that means it's going in the negative x direction. And I can say that it's going slower than section A because it has a flatter slope. The steeper it is, the faster. C is less steep than A, therefore it's going slower. Now, if I want to put some numbers on it, I can do some qualitative stuff. There's a couple things I can do. Now, from t equals 0, t equals 4, what's going on? Well, we know it's going at a constant speed, constant velocity in plus x direction. Okay? But we can do a lot more than just say that. We can give the velocity. Remember, the velocity is the slope. So we're going to do v is change in x over change in t. All right, it's usually y over x, but on my y-axis I have x, on my x-axis I have t, so change in x over change in t. I'm interested in the first 4 seconds. So this spot is 0, 30. This one is for negative 30. So when I do my change, okay, my y value changed from positive 30 to negative 30. So I'm going to do negative 30 minus 30. I always do the second one minus the first one. And these were in meters. I'm going to divide that by 4 minus 0. So I subtract my x's, this, or my y value, this one minus this one, and I subtract the times that one minus that one. When I do this, I get negative 60 over 4 meters over seconds, or minus 15 meters per second. So that's the speed of it, is 15 meters per second, and negative means it's going in a negative x direction. Now, I can also find the displacement and the distance. Remember, he went from 30 to negative 30. If I start at 30 and I go to negative 30, how far did I go? I went 60. Right? I started up here at 30 meters, and then down here at negative 30, that's a difference of 60 meters. And my displacement, what's the difference between distance and displacement? I have to include direction. So I could say my displacement is minus 60 meters, or I could say 60 meters in the negative x direction. Okay, now I'm going to change colors to do the next section. Alright, I'm going to do from t equals 4 to t equals 5. Just describing it. It's going at a constant speed. How do I know it's constant speed? It's a straight line. And it's in the plus x direction. Okay, it has a positive slope. That means it's going in a plus x direction. Now, for more detail, I can find the velocity. That's the slope. Change my y divided by the change in my x. So for this one, it goes from 4, negative 30 to 5, 0. So I'm going to take my second y value minus my first y value. So 0 minus negative 30 meters over. And then my time is 5 seconds minus 4 seconds. So 5 minus 4 seconds. It's going to give me plus 30 meters per second. So it's going faster, right? Before it was going minus 15, now it's going plus 30. How could I have known looking at it? I could have known because it's steeper there than it was from 0 to 4 seconds. Now my distance for this part, remember it went from negative 30 to 0, so that's a change of 30. So delta x is 30 meters. Now, I can also figure out the displacement. Okay, the delta x for displacement. You use the same variable even though they're different things. Distance out is how far you've gone. Displacement is how far you've gone and in what direction. And it's going to be plus 30. It started at negative 30, ended at 0. That's a change of positive 30. Now, we'll do one more color for the whole trip. Okay, I can find distance for the whole trip. Okay. Remember, for distance, direction doesn't matter. So first he went 60 meters, then he went another 30 meters. That means he went 90 meters altogether. For my displacement, okay, now direction does matter. I went minus 60 meters at first, or 60 in the negative direction, and then I went 30 meters in the positive x direction. So altogether, the displacement is negative 30 meters for the whole trip. You can actually see that on the graph. If I look at the whole trip and just look at the endpoints, it started at positive 30, ended at 0. What's the displacement? The displacement is negative 30. He ended up 30, where he started from, in the negative direction. For my distance, he started here at 30, went all the way to negative 30, which was a distance of 60. Then he went in the positive x direction for another 30. So he went 60, and then he went 30 back up the other way.